Imagine discovering a spider at the bottom of a lake, not floating, not drowning, not trapped, living there, permanently. At first, that sounds impossible. Spiders breathe air. They evolved on land. They don't have gills. They don't extract oxygen from water like fish. So, if you find a spider living underwater, something has gone terribly wrong, or evolution has done something extraordinary. As it turns out, the answer is the second one. Hidden beneath the surface of ponds and lakes across parts of Europe and Asia lives one of the strangest spiders on Earth. A spider that spends almost its entire life underwater. A spider that hunts underwater, eats underwater, mates underwater, raises young underwater, and somehow breathes underwater. Meet the diving bell spider, the only spider known to live nearly its entire life submerged. And the way it survives is so clever that for years people struggled to believe it. Because this spider doesn't breathe water. It brings air with it. Imagine a human deciding to live at the bottom of a lake. Instead of developing gills, they build a house filled with air. Then they simply carry fresh air down from the surface whenever they need it. Ridiculous. Except that's essentially what this spider does. The first time naturalists observed diving bell spiders, they were confused. The spider would repeatedly swim to the surface, then return underwater. Again, and again, and again. It seemed inefficient, almost pointless, until researchers looked more closely. What they discovered was astonishing. The spider wasn't simply swimming, it was collecting air. Its body is covered in tiny, water-repelling hairs. When it visits the surface, these hairs trap a thin layer of air. A shimmering silver bubble surrounds much of its body. The spider then carries this bubble underwater, like a diver carrying an oxygen tank, but instead of keeping the bubble for itself, it deposits the air somewhere else. Its home, because before the spider can live underwater, it has to build something, an underwater house. And not just any house, a house made of silk. At first, the spider anchors silk strands between aquatic plants. The structure resembles a loose framework, almost like the frame of a tent. Then the spider begins transporting air bubbles from the surface. One trip, then another, then another. Hundreds of tiny deliveries. Gradually the structure inflates. The silk fills with air, expanding into what looks like a transparent underwater balloon. Scientists call it a diving bell. Which is fitting because humans once used a very similar concept. Early underwater explorers lowered giant air-filled chambers beneath the water. The trapped air allowed people to breathe underwater temporarily. The spider independently evolved the same idea millions of years earlier, only much smaller, and arguably more efficiently. Inside this air-filled chamber, the spider can rest, digest food, avoid predators, even sleep, all while remaining completely underwater. The diving bell becomes its living room, its bedroom, its dining room, its nursery, its entire world. Which raises an obvious question. If the spider traps air inside the bell, wouldn't it eventually run out? After all, oxygen gets used up, carbon dioxide builds up. Eventually the spider should suffocate. Scientists wondered exactly the same thing. The answer turned out to be one of the most remarkable parts of the entire story. Because the diving bell isn't simply a house, it's something much closer to a biological submarine. At first, researchers assumed the spider constantly needed to refill its air supply. That seemed logical. Use oxygen, run low, collect more, repeat, simple. But observations didn't quite fit. The spiders were spending surprisingly long periods underwater. Longer than expected. Sometimes much longer. Something strange was happening inside the diving bell. Eventually, scientists discovered that the air chamber functions like a physical gill, one of the most elegant solutions in the animal kingdom. Here's how it works. Water contains dissolved oxygen. Fish extract it using gills. The diving bell does something different. As oxygen levels inside the bell decrease, oxygen dissolved in the surrounding water naturally diffuses into the air chamber. Fresh oxygen enters. The spider continues breathing. The underwater air bubble effectively pulls oxygen from the surrounding water, almost like a rechargeable oxygen tank. It's an incredible system. Not perfect, but remarkably effective. The spider still has to replenish air occasionally, yet far less often than scientists originally believed. Nature essentially turned a bubble into a breathing device. And the deeper researchers looked, the stranger things became. Because living underwater creates another problem. Movement. Most spiders walk, they climb, they crawl, the diving bell spider swims, and surprisingly well. Its rear legs are covered in specialized hairs. These hairs act almost like paddles, allowing the spider to move efficiently through water. Watching one swim feels slightly unsettling. Your brain knows spiders shouldn't be moving this way. Yet there it is! Gliding through underwater vegetation. Perfectly adapted to an environment where almost no other spider can compete. And competition matters, because underwater hunting can be extremely rewarding. The spider feeds on insect larvae, tiny aquatic creatures, small crustaceans, even animals larger than itself on occasion. When prey approaches, the spider launches an attack with startling speed. Venom quickly immobilizes the victim, then the spider drags the catch back to its diving bell. Imagine being a mosquito larva. You're worried about fish, perhaps other aquatic insects. The last thing you expect is a spider emerging from the darkness, yet that's exactly what happens. The diving bell spider occupies a niche that few predators exploit, and because of that, it thrives. But perhaps the strangest part of all is that the diving bell isn't only used for hunting and survival, it's also used for family life. Everything important happens inside that underwater chamber, including courtship, and that's where things become surprisingly risky. Male diving bell spiders face a challenge. They must locate females hidden among underwater vegetation. Not easy, especially in murky water. Eventually a male finds a female's diving bell, and then comes the difficult part. Approaching. Because spiders are not always known for gentle introductions, many species are dangerous even to potential mates. The male must signal that he's interested, not edible, a distinction that matters greatly. Researchers have observed males carefully entering female diving bells. The pair communicate, courtship takes place, and if successful, mating follows. Remarkably, all of this happens underwater, inside a chamber of trapped air, hidden beneath the surface. Afterward, females construct specialized nursery chambers. Eggs are laid, protected, guarded. The next generation develops entirely within this submerged world. Young spiders eventually emerge and begin building lives of their own, never needing to leave the underwater environment, generation after generation, for millions of years, and perhaps that's what makes the diving bell spider so fascinating. It solved a problem most spiders never attempted to solve. The challenge wasn't simply surviving underwater. Many animals do that. The challenge was remaining a spider while doing it. No gills, no radical transformation, no fish-like body, just a spider, using silk, air, and physics to conquer an entirely new world. Evolution often works this way. We imagine dramatic changes, completely new designs, revolutionary innovations, but sometimes nature achieves something extraordinary using familiar tools. The diving bell spider didn't become a fish. It didn't become an amphibian. It remained a spider, and simply changed how it used the resources around it. Silk became architecture, air became technology, a bubble became a life support system. The result is one of the most unusual lifestyles in the animal kingdom, a predator living beneath the surface, breathing from a portable atmosphere, sleeping inside a bubble, raising a family underwater, and proving once again that reality is often stranger than fiction. The next time you look across a calm pond, it's easy to assume nothing unusual is happening below. Maybe a few fish, some insects, plants swaying in the current, but somewhere beneath the surface, hidden among the vegetation, a tiny spider may be sitting inside an underwater house made of silk and air, breathing, waiting, watching, completely at home in a place where almost no spider should be able to survive. And that's exactly why the diving bell spider remains one of nature's greatest engineering marvels.